Okay, and if you're on this call, if everybody can just make sure that they're muted out or that you're muted out. We're going to keep this call to about 60 to 90 minutes. Most likely it'll run a little bit long, about 90. I got a PowerPoint that I'll bring up to help keep us on track with some different bullet points and some announcements we're going to make. And so if you're ready, Eric, we'll get it rolling. Okay, and this video is being recorded, and so this will be made available on YouTube once it's done. And so today is February 4th, Saturday, noon, Pacific time, and I have Eric Dollard on the line. This is Aaron Murakami with eMediaPress.com and the Energy Science and Technology Conference. And so let me see if I can get this screen up. We had the PowerPoint right there. Okay. We also have Dr. Adrienne Marsh and Haka Says and Griffin Brock on here. And they're going to be contributing to this call. Okay, hold on. I got all these little admin messages popping up and stuff, so I can kind of getting used to this. So anyway, Eric Dollard and EPD Laboratories Inc. is down in West Central Nevada, and EPD Laboratories Inc. is a 501c3 nonprofit organization. It runs solely by donations, and all donations are tax deductible. If you go to ericpdollard.com, which you can see there on the screen, and scroll down in the right column is information on how you're able to donate. You can donate by mail, which would be to this P.O. box here in Spokane. And then most people donate by PayPal, which if you scroll down a little bit more, you'll see a donate link. And all donations are greatly appreciated. You know, there's everything from property tax to insurance to buying parts to, you know, keeping the lights on literally. And so whatever, any amount of money anybody can donate would be greatly appreciated. Sometimes we get small donations, most of them. Once in a while, we do get some big donations. Last call on, I believe it was December 17th, there was a couple people who made some significant donations, and that helped to cover some of the costs for Justin to come down to the shop there in Tonopah to do some work, and we'll be showing some pictures on that. And so basically, I'm just going to flip through some of these slides, and then Eric can kind of narrate what's going on. I do want to show this real quick. These are all the websites that will probably be referenced in one way or another. The top one, ericpdollard.com, is where you can donate. Let's see, that just moved by itself. The next 5 websites are my websites. The eMediaPress.com is where all the books and videos are available. There's over 225 books and videos. Some I authored and presented. Quite a few are Eric's and other presenters from the conference. And EnergyScienceConference.com, I'm going to be posting, we're actually going to be opening up for tickets here probably by Monday or Tuesday. And then, of course, there's Griffin's and Dr. Adrienne Marsh's website there at the bottom. We'll try to post this in a chat so everybody can screen copy or copy that out of there. I don't know if Haka Says has a website. I don't believe so. And if you do, you can.
I do, but don't worry about it.
Type it. Okay, I actually didn't know what it was.
Mostly just the calculator.
Okay. Let's see. So the Energy Conference is coming up in July, which is going to be July 5th through 9th. It's Wednesday through Sunday. It's a 5-day conference, jam-packed. It'll have about 17 presenters. There'll be maybe close to 20 presentations because a few presenters will be presenting 2 presentations. And this is in Spokane, Washington. That's all the way on the eastern side of Washington State, not too far from the Idaho border. Last year, we had it at my shop. That worked out really well. We're going to have it there again. We're going to be limiting the in-person tickets to 65 this time. Last time it was 50 because we had limited space and didn't know how many people we could get in there. But it looks like 65 in-person tickets. And we're also going to be having live streaming with Vimeo. That worked out really well last year. And so we'll be posting those pretty soon. So if you're too far away, or if the costs are a little bit too high for you to be able to come to the conference in person, you will be able to stream it. And that website is EnergyScienceConference.com. So Eric, do you want to kind of explain a little bit about your solo presentation? It'll be about 4 hours long. And let me see, there you go. Yeah, so what is your presentation going to be called, and what is the 4-hour presentation going to be about?
Well, it's kind of early to say how many hours it's going to be, and the title's not quite clear yet, but it started off, let's see, the last presentation I did on polyphase power is going to be turned into a book, but that presentation had no chapter 1. So I started writing that, and one thing led to another, and of how Tesla conceived polyphase, and how it was laid out, and his whole 4-phase system, why it was 4-phase and not 3-phase, and one thing led to another, and then all of a sudden it became it's turned into a massive effort. So it'll start off of Tesla's inception of polyphase, and then get into the 4-phase system, which not a lot of people really know about. It's wrongly called the 2-phase system, but as is seen from my presentations on polyphase, most of the terminology is wrong, so I have to set it right. So I'll get in very heavy into how everything was configured at the 1893 World's Fair, where the 4-phase system was constructed to illuminate the entire World's Fair and a multi-megawatt level system. And I'll get into the details of that. And then that's followed by the details of the Niagara project, which was such a convoluted and twisted political, sociological, international effort that it almost serves as a complete analog of the world that we live in today. It's amazing anything came out of that worked correctly, but it did. And Tesla and Westinghouse prevailed, and that's where the 4-phase to 3-phase transformation process was developed, because 3-phase is more economical to transmit than 4-phase. So I'll basically, right now, presently, I'm doing all the mathematical experimentation to analyze that 4-phase, 3-phase conversion, which is difficult, never really been fully complete. And also I'm getting into the whole basic root theory of polyphase built around 4-phase, which has a lot of advantages over 3-phase and other phases, in that intrinsically alternating current is a 4-phase process. So a 4-phase electrical system mimics the alternating current itself, and brings out a lot of features that are lost in 3-phase. And at the same time, it also extends the whole notion of the Cartesian coordinate system beyond what it is presently understood as. And then after that, I'll get into the Fortescue analysis of the 4-phase, and come up with the complete sequence algebra for 4-phase, which has never been done. So this is part of what's inspiring me to keep going here, because every page I'm discovering new things, and it's turning out to be quite fascinating. It's kind of addicting almost once I get started. It's like taking a hike in the forest, and you can't stop because you want to know what's over the next hill. And that's kind of where I'm at now. So the whole Fortescue thing is, I haven't started developing that in its full extent yet, so that's coming up. And then the musical aspect of it, I found a piece of Bach music, which is very basic. It's called the Prelude and Fugue in A major, and it's 4-phase, within 4-phase all throughout. So I think something I've been wanting to do for a good fraction of a century was completely equate polyphase with polyphonic. So will most likely have the time, if I can get the help from people that were more competent in music than me, to completely analyze that piece of music as a four-phase system. And then that should pretty much wrap up the presentation. So, and then also this presentation will be its own book, which will basically be the theory, history, practice, and what have you of the Tesla four-phase system. And the certain parts of that will be the chapter 1 of the Fortescue book that was 2 years ago that I did, assuming that I can keep all that on track and what have you, because it's a really big project. So basically, I have to write up this upcoming presentation before I present it. Otherwise, I won't be able to do it without stumbling and being spaced out. So I'll probably disappear into the forest in Oregon somewhere and spend a month putting that together. A couple of weeks before I actually give the presentation. That's normally how I do it. So that's kind of what the presentation is going to be about.
Okay. Some of the other presentations, there's going to be a co-presentation with you and me on the audio rack. I just want to show a picture of that real quick, and then let's see if I get this thing to cooperate. Can everybody see the those two rack units right there that's showing up? Okay, so the one on the right is an RF rack. The one on the left is the audio, or bay, I should say.
Yeah, so that's a terminology. Is the rack is what the units go in, and then the full assembly is called the bay.
Okay, and so this presentation in April, Eric will be up at my shop, and this audio unit is, for the most part, it's complete. All the parts are built. It's mostly wired up. There's a little bit of extra wiring, and then each of the units or components in there, like the scope at the top, the 810 amp, and the rest of them will have to be tested. And then do you want to kind of go into a little bit about what this is?
Basically, this is about a 1,000 watt audio amplifier that produces that power at 2,400 volts. So it's, in a certain sense, it's an enormous signal generator. And the purpose of it is to be a power source for various experiments. I think the original thing that that spawned this was doing water separation experiments with complex audio frequency waveforms. And then now, later on, it's also turned out to be a possible power source for the electrostatic induction machine operating as a motor. So that's kind of, that'll probably be one of the primary uses of this if there's ever a point in which that motor gets built. And then the main thing right now is this is the audio modulator for the RF bay to superimpose the music on the discharges and to start making more complicated waveforms to see how these organic growths that appear can be made to be even more organic or more interesting. So this, all, of course, is yet to be seen. It's all highly experimental.
And this whole thing was, yeah.
Go ahead.
I was just going to say, and this whole thing is pretty much made from scratch, except these light gray signal generator and scope, old Hewlett-Packard ones from eBay, but all these other ones were pretty much all fabricated from scratch. Some of them, even the chassis and the panels, were fabricated. They weren't bought from Hammond. Some of them were, and we were lucky that we found all matching meters and switches and everything. And it's been a pretty expensive project. And so hopefully, you know, if we have the audio one done, and then as time permits, you know, at some point we'll be completing the RF one, and they can be used independently for different experiments, or they can be merged together.
So basically, the objective with the RF bay, if possible, is with the upcoming conference, if there's adequate funding and what have you to keep me going on this project, is to get the output of the Collins up to about 1,500 watts, 2,000 watts, and audio modulate it, and then have the custom light bulb custom made, and then basically there was about 120 watts available in the last showing, and in this case there's going to be about 1,200 watts available. So it'll be interesting to see. At that point, the light bulbs will explode, and the most interesting stuff in the light bulb is just before they explode, which kind of makes it difficult because you're cringing waiting for the blast. But that's when you see the good stuff. So maybe that all could be done. So can you go back to that picture again?
Can you see that?
Yeah. So the first time around, okay. So basically, the audio bay is pretty much complete. It's just a matter of testing and measurement. The radio frequency bay, the rectifier and network unit at the bottom is all assembled, which basically provides the DC power, either 2,400 volts or 4,800 volts, depending upon the mode of operation. And then the network takes out all the power line alternations, so you don't get hum and all that kind of stuff. And then also, that would be a low pass network. And then there's a high pass network that the modulator is, its 2,400 volts is superimposed upon the 2,400 volts of the rectifier on the bottom of the radio frequency bay, which produces the 100% modulation. And then on the top, with the four meters, is the that's the actual RF power amplifier, and the Collins will go in the place of the exciter that's in there now below it. The grid control unit is not constructed, and the output tuning unit is not constructed. And the panel with the 3 meters going across is the medium voltage rectifier for the power tubes, which is mechanically constructed but not electrically constructed. So it'd be yet to be seen, what could get finished and whatnot. But the rectifier and its network on the bottom is ready for testing. So basically, this time around, anything that is done and ready to be tested will be tested.
Okay. Let's see. We can get some little bit of input from I think Adrian. Do you want to talk a little bit about what your presentations are going to be?
Well, thank you, Aaron. Hello, everyone. This year at ESTC, I'm going to do 2 presentations. I started a theme last year in 2022, where as part of my demonstration, I demonstrated the golden ratio discharge. And this is a discharge first discovered by Eric Dollard in 1978 as part of the Integratron work that he was doing. And then something that I rediscovered in 2020, 2021 as part of the Will Work of Nature, the Will Work of Nature experiments that I started in 2017. So my main presentation will be the golden ratio discharge. So I'll be going into a lot more detail about the origins of the golden ratio, fractal discharges, and then looking at the generator and the system and the characteristics that actually produce that golden ratio discharge, and also asking some of the more fundamental questions about, well, where does that discharge originate from? I mean, why is that discharge so different to what we would ordinarily see from a Tesla coil? I mean, there are thousands and thousands of videos on YouTube on all Tesla coils and different generators of many, many varying types, but you don't see the golden ratio discharge from these. So I'm going to be talking a lot more in detail on that. I will be doing a new demonstration this year. So I will be going much deeper I will be using a different generator, a more powerful generator, which produces a much greater spread, a much larger discharge. That's provided I can get it all the way from the UK to the US in my case, which I managed to last year. So I'm planning it again for this year. The wheel work of nature experiments was something that I started in 2017 to probe the fundamental nature of electricity. And I'm talking at a level which goes deeper than, for example, the magnetic and the dielectric induction fields. So, in other words, trying to look at experiments that show more of the origins or the underlying principles and processes that are in line with the process of nature. Tesla, of course, made that very famous quotation about there will come a time when man will learn to hook their experiments, machines to the very wheel work of nature. And I think he was saying something very important in that. And the wheel work of nature experiments are designed to try to probe what are the underlying origins of the principles of electricity and how those play out and why they should be in accordance with other principles in life. So that presentation will cover a lot of things. It will be quite technical in some places. It will also cover the engineering and the primary characteristics of what is necessary in order to create that golden ratio discharge. Actually, it's not very difficult to create that discharge, provided 3 or 4 key characteristics are part of the apparatus or part of what was put in to that apparatus. And I'll be going over those in detail. So in effect, following the presentation that I give, it should be possible for anybody that's working with Tesla coils to be able to set up those experiments for themselves and then be able to observe the golden ratio discharge and experiment with it. And also later in this discussion, I'll be talking a little bit about where I've got to with the research and what I'm currently doing with that. So that's the other presentation. That's the first presentation. The other presentation is something quite different from what I would normally present on. So typically I would present on Tesla coils and electromagnetism, RF, and all the technical side of the research. But the other presentation, I'm going to look at the other side. I'm going to look more at the esoteric side of the principles of life. I'm going to be talking about what's called the Toltec system of knowledge. It's very not known about in the world. It's something that I've followed for over 20 years now, and it gives a very great insight into the natural order and how things go together. It is obviously something which I'm also incorporating in my work in the wheel work of nature. So I will be introducing the Toltec system of knowledge. It'll be about a 90-minute presentation. I will go through its origins, its history, its key principles, and how those principles are useful and where they play out in life, and how those can be related to the work that we're doing in the new science. So for me, really, the two come together as an exploration of the new science. So I make a distinction between the new science and conventional science. Conventional science we know very well. It's a lot out there. It's easy to read about in many places. But the new science is something that goes further. It asks many questions that are not ordinarily asked within conventional science. it captures things in a broader range of things. It's something that ESTC and Aaron has been involved with for many, many years, and many of the people here also are involved in some way in the new science. So I will be looking with those two presentations to form a bridge between what we would call science and engineering and technology, and what we might consider to be more the underlying principles of life. And it is that bridge which really forms the core of the research that I do. So AM Innovations is a not-for-profit organization which run by me. All the research is self-funded, and it is supported by what is called the Foundation for Toltec Research. So that is where those two things also come together. The Foundation for Toltec Research is also an organization. It's also headed by me, and that is where that bridge between the two sides of the research get brought together. Okay, thank you.
Now, I just posted the links again in the right column. And if you're just recently joining us, some of us are just kind of sharing what a little synopsis of what our presentations are going to be about. Dr. Marsh's website is the last one listed there, am-innovations.com, and you can go there to learn more about his work. And then let's see, I'll bring on Hakases and then Griffin to kind of go over a little bit about their presentations. And then I believe they may have a co-presentation as well. Let's see. Okay.
Okay. Hi. Thanks, Aaron, for getting everything together. So Hakases, last year I presented Build the Tesla Coil the way Tesla built them, which was meant to be a very low level and simple sort of starting ground to get the amateur engineer, somebody that was interested, a foothold to actually start doing experiments. This year, I think it's going to be called Slaying Maxwell's Demon, where I want to go over some of the more academic concepts and theories from Eric Dollard or Steinmetz and some others to try to start breaking down the principles and break down where conservation breaks down. I want to kind of highlight some of the mechanisms to the asymmetry and kind of go over what experiments we might do or devices we might build to try to prove or falsify them. So going over like the rotary electrostatic converter, the Carson motor, or you might know as the John Trump motor, magnetic amplifier, Alexander alternator, and try to put as many threads together as we can so that we're all starting from a similar and self-consistent framework. And then in the practical demonstrations, it really depends on what kind of luck we have this year, especially now that I got one of the radiant matter tubes from Griffin. I'm starting to work in that field as well with my own equipment. So we're going to take that as far as we can, and fingers crossed. That's about what I got.
Okay. And then let's see, Griffin, do you want to cover some of what your presentation is going to be about?
Oh, certainly. Thank you for hosting this Zoom meeting. I would say since my schedule and idea of, for the two presentations possibly that I'll be covering are still quite tentative, but as Jeremy slightly alluded to, that one of them will primarily cover certain single cathode electrode lamps, which Tesla devised. Now, for the past 2 years, I would say, I've been highly interested in replicating certain lamps which Tesla was able to put forth in the latter half of the 19th century, and really haven't seen replication till this day. Now, I've noted that there are some quite unusual, peculiar effects associated with such single wire lamps, and some of them I was somewhat successfully able to demonstrate last year. But for the most part, I would say maybe only a couple months ago, I was able to demonstrate the rotating brush effect, as well as certain radiant matter experiments, which have not exactly seen the light of day since that time. And of which those experiments involving certain lamps have raised question and concern, as well as the effects of these lamps in which they produce. Now, I will likely cover this in the Zoom call over my very recent research into the effects of such rays which emanate off these bulbs and the surprising effect which it has on biological life. Now, this is to say with other lamps, including the carbon button lamps and lesser known lamps which Tesla devised. So that'll likely be one of my presentations for this year's conference, as well as a project which Eric Dollard has been able to assist me on. It's a specific type of amplifier designed for seismic forecasting. It involves a rather unique and rather unseen design perfected by Dollard, but of course it's still highly experimental, and I'm in the work of constructing that. Now, I have posted pictures on my website as well as other descriptions of the current seismic forecasting racks and transmitter units which I currently have and have been constructed. Those will also likely see some information disposed at the conference, but for the most part, it'll likely be concerning the amplifier, as it truly is a new field of research concerning amplification. And of course, I guess with any joint presentation with myself and Hawkes's, that we're not entirely certain on at the present, but it could manifest into something.
Okay, I think there's a time slot on the conference, the tentative schedule right now, so it remains to be announced. So for anybody who's just joining, I just want to, let me post this real quick. So this right here, you're hearing a couple little tidbits of some of the presentations that will be at the 12th Annual Energy Science and Technology Conference in Spokane, Washington, coming up here in about a little over 5 months, July 5th through 9th, Wednesday through Sunday. There'll be about 17 presenters, maybe about 20 presentations. And if you have any interest in any of this type of work, anything dealing with Tesla, this conference is a must-see. You're not going to see these type of demonstrations or these kind of presentations at any other event. I'm sure of that. Let's see, we can go on to the...
they look much cooler in person too.
Yeah, for sure. Okay, let's get into the new book. So Griffin has helped to edit or actually transcribe one of the books in Eric's series dealing with Oliver Heaviside. And if you want to kind of go into book number 2, Eric, hold on a second. Let me get you up here real quick and let me show the book cover. So this right here, Electromagnetic Induction and Its Propagation, a sequel to the work of Oliver Heaviside of the same title, Part 2. Part 1 is available as a paperback in Amazon. If you go there and type in Eric Dollard, you'll see a cover that looks similar to this, except it'll have a like a tower with some insulators, I believe, kind of up close, cross arms or something. But this Part 2, this is available as a digital download on eMedia Press right now. Book number 1 and number 2 are available as digital downloads, and you get a significant discount if you get both. Just by adding Part 1 and Part 2 to the shopping cart, it'll automatically give you a discount. Part 1 is a paperback, is only available on Amazon right now. Eric and I are both waiting for proof copies so we can go through and do a final review. And if it looks good, hopefully within another 1 to 2 weeks, Part 2 will also be available as a paperback on Amazon. Do you want to kind of give a overview, Eric, of what this book is and what it covers? And I'll show a table of contents after.
Okay. Well, actually, parts 1, 2, and 3 are the book form of a presentation I gave, what was it, 2 years ago by the same title?
Yes.
So fortunately, before I gave that presentation, I had written it up. It took, I'd say there's almost 4 years of effort into assembling this material. And the material is a result of work that started with my interaction with Philo Farnsworth. And I would say right now, you're looking at basically my entire adult life work and research into this mathematical representation of electricity, which has never been done. It's always been in the hand of abstract physicists who convolute and distort and misrepresent and obfuscate, and to the point now that one of the reasons why I'm doing the work on the polyphase and that type of stuff is there's no one left that understands any of this stuff at all. And the whole power grid is starting to spiral into a choke down because of it. So I will no longer, the Heaviside books will be my last highly theoretical works, which I think there's really actually so few people really interested in that. It doesn't justify my efforts anymore. So I'm going to be henceforth be concentrating on more practical engineering type stuff. But in this part two will be the first representation ever of so-called Maxwell's equations in a term that is understandable and actually has some kind of relevant meaning. And it was not easy, but I did manage to get it simplified down. So in a certain sense, these works, part one, then part two, and part three, are the extension of what has been in kind of the slang term as the Lone Pine writings. But now, it's not something that I did for fun in the bushes anymore, with sneers and snipes and childish statements to entertain people. This is more down to earth now. So it was not easy to put this together because the figures and the presentation did not have the serial numbers as the figures in the notebooks, and the presentation was basically the material was not finalized. And I think Griffin can agree with me that this is a real son of a bitch to untangle. And a couple of times I almost threw the notebooks against the wall in frustration, but we broke through and here it is. So it's very thorough. There's nothing more than basic first year algebra, and it finalizes on an actual transmission line, which is the one shown on the cover. That Steinmetz had analyzed in his transient phenomena book. So basically I used Steinmetz's example. The tower on the cover was one that goes to Lone Pine, which is a very historic circuit called the California Electric Line. And it has the same characteristics as the one Steinmetz analyzes. So I simplified the thing by taking the conductor resistance and the insulator conductance out of the equations and just leave the electromagnetic part. So the mathematics is simpler, and quite fascinating putting all this together and actually seeing this stuff in such a simple form rather than the convolutions you usually get out of a textbook. So I try to do this, and all this stuff is to have a practical example following Steinmetz's methods in his book. He always has practical examples, so you can actually make use of the stuff that he's presenting.
Right.
Okay. You want to mention?
Crazy.
Can somebody mute yourself out, please? Okay. Did you want to cover anything else on the book, or do you want to go right into the shop projects with what Justin's been doing, the shack and the building? And I have those pictures.
Yeah, let's do that.
Okay. Okay, so this is going to be the EPD labs. There's a little transmitter shack up on top of the hill. and some stuff that's been going on in the buildings. And again, with the donations from the last call, that's what helped to make it possible for Justin to come to Tonopah and help Eric with these. And I'll click on some of the pictures, and Eric can narrate them. But real quick, again, EPD Laboratories, Inc. is a 501c3 nonprofit, and it operates solely by your donations. And if you go to ericpdollar.com, scroll down in the right column, and you'll see a mailing address in Spokane where you can send checks or money orders, or the easiest way is to donate by PayPal. And there was some significant donations that came in after last call, and that's what helped to make some improvements on the building and to repair some things up at the transmitter shack. And so I'll get to those pictures, and Eric can tell you kind of what's been going on here. So I know we had put the stairway up in the past, and I think that the boards were cut not at an angle or whatever. So what's going on here, Eric?
Well, the whole thing was a cob together, so it wasn't really safe, and it looked like hell and all that. So the weather's pretty bad here right now, you know, unless you like living in sub-freezing temperatures while you work. But when it got like that, then we worked on stuff inside the building. So there's a couple of major things inside the building. There's a roof leak that's got to be dealt with, even though we paid for a new roof. Is typical, you know, what you pay for, you don't get. But the stairway thing was easy. It really needed to be cleaned up. So that was done. And then some doors have been put in to stop the wind from blowing through.
So Eric, the pictures I have are not necessarily in any particular order. Okay. If I just go in sequence, if you just want to kind of go, it'll be a little bit random, but.
Well, one of the things is the mud hole in the backyard, which makes it almost impossible to do anything. So it will take 144 buckets of gravel to deal with the mud hole. And there's no problem finding that around here, because there must be 1 million tons of mine tailings everywhere. There's so many mines here, you know, from the size of a coffee can hole in the ground to something that has basically hollowed out entire mountains that you can get almost virtually any kind of local rock you want. So this is what's going on here, is to start filling in the mud hole. This is the radio box. I'll have to get into kind of the whole history here. So what was provided to us was the remains of the old cable TV company. So that there was a cable TV head end shack and 2.2 miles of poles, for what was left of them, to put in transmission lines on to connect to this shack and to connect to the mine. So everything done with the cable TV company was about as cob as could be. So the vandals had gotten into this before we got it, and it was just there. There are pictures in the archives of this thing was nothing. It was ready just to blow away in the wind. So we did an initial securing of the building when it became ours, and then some ham radio effort was put in there to get the thing on the air on this frequency of 144.390 megacycles, which is a national kind of telemetry network for weather. But what's interesting about this network, and it's very widespread, is there is an extra channel for us to put the measured output of the ionospheric seismic antenna onto this link, so we can get something out on the air. But unfortunately, the people that put the equipment there, it was a hit and run thing, and we don't have time, and all the usual crap I get from people, and they ran away and left me with something that didn't work and what have you. So now we have to strip all that down, presently the equipment is being put into regular racks, the proper grounding, antennas, the RF shielding in the building. The whole building has to be lined with rodent wire and what have you. And the shack virtually had no integral or no integrity strength-wise. So a lot of carpentry work, massive amount of carpentry work to set this thing straight. I think just alone, it was almost $2,000 just because the cost of materials are so high now. So what made this possible is somebody had donated, I think, about $5,000, and every month out of my fixed income, my Social Security and what have you, I always try to save a couple $100. So over the course of an extended period of time, I managed to come up with matching funds, because as hard as it is to believe, and as sickening of a reality it is every little increment of this project is $10,000. Every significant increment of this project, which has not been possible, that's why we're going the low budget route to get the signal on the air, is $100,000. So this is what we can do with the money on hand. We can get one signal out. It's going to consist of 3 episodes, of which this is only 1. The wire still all has to go up on the poles. There's been massive past episodes of replacing rotten poles and dangling wires and going out to Death Valley and climbing old railroad telegraph remains and what have you, which has been going on for almost a decade now, just to get to the point where we can finally get something on the air. I still cannot get the seismograph transducers on the air because we just can't get the money to secure the entrance of the mine to put the equipment in. So this is going to be kind of the what we can do with what we got, because the effort is always, when anytime any money comes in, you know, I'm not gaining any weight, you know, and what have you, is I pinch on all of that.
So Eric, in simple terms, this transmitter shack, what information is it sending out that people can pick up? Is it basically weather information?
Well, it started off, this ham radio link is used for weather, so, you know, wind, speed, and all that. So, but it does have other channels. So it was actually, when this thing was operating, it was kind of, there were various universities that were using this information because we basically have the only site in this entire part of Nevada, because we're in the middle of the deadest dead desert, I think, that the United States owns, and there's nothing around here. The nearest anything is a 100-mile drive, but it took a crap. So that's why I decided to stop fooling around with this jury-rigged, you know, stuff. The people that install it won't help me keep it running, and we're just starting all over again and get that weather thing back on the air, get it reconnected to universities, and then put one electroseismic parameter in, which will be the ionospheric noise measurement, which I've found from Landers and also some of the experiments that Griffin has done, and sensing that I have done traveling in my car into the remote wilderness and listening to signals, that 18 hours before a major seismic event, there is an ionospheric noise storm, carries for quite some distance. The one from the Japan earthquake carried all the way over to Landers and basically was full scale for 48 hours. So we have enough wire, we have enough poles, we have enough insulators, we have enough parts and what have you, that when we get this cable TV shack looking more Navy than ham radio, we'll be putting this out on the air, and then Griffin will also be putting together a companion unit so we have stereo, which is important because it's very important to have 2 different sensing stations so you can start to get an idea of where this stuff is coming from.
Okay.
So that's the objective right now.
I think I showed all the shack pictures. I can show some of the inside ones now. Is there any update with what's going on with this picture?
Well, nothing's happening here right now because it's not possible. Material handling here is not possible. There's no way to organize stuff. There's no shelves. There's no cabinets. There's very few benches. That's some desert junk. So those racks, go back to that picture. I don't know why it changed.
Here, just a second.
This is what's supposed to go in the portal to the mine. This is what we're kind of approximating right now in the cable TV shack, but everything on the right of the picture is what goes into the portal of the mine. What's on the left of the picture is kind of just more of a staging area for Navy type stuff, but on the right is the Bell Telephone stuff, and that's what will do all the seismograph signal processing. It will do the antenna signal processing, and then this stuff will go out in its full glory on the internet, if it ever gets to that point. So we do have all the materials, but we do not have a way to manage the materials or the necessary shop and facilities of that matter to really do much of anything. So basically, this is in limbo right now. There'll probably be points, you know, if I can get, you know, Justin to come here more often, these racks might start getting filled. There's supposed to be an analog computer built to modulate and manipulate these signals. That has to be built from scratch. There's various amplifiers have to be built from scratch. So this is back to the shack. Gives you an idea of the, now I don't know exactly what was before or after, but almost everything you see done in here was to give this shack some kind of integrity so it doesn't blow away in the wind, to keep the rats out, the RF shielding, keep the weather out and all that. So this is just more plumbing in the building. This is the doors that gone up to keep the wind from blowing through, to at least be able to keep some of the spaces warmer, keep them above freezing, which is very difficult right now to keep the inside of the building above freezing this time of year. So that was successful. A lot of little stuff like that, maintenance things that just have to be done.
Okay. Let's see. I guess we can get into some of these other project updates. I do want to mention that in April, Dr. Marsh is going to be coming from the UK to Spokane for about a month to work with Eric and myself at the shop. Possibly Haka and Griffin might come up, or at least are welcome to work with some stuff, work with us up there at the shop here in Spokane. And with Dr. Marsh coming over, it's going to cost a little bit of money for you know, food, lodging, and travel and that kind of stuff. And I'm not sure exactly what all's on the agenda, but if anybody is able to pitch in to help cover some of those costs, it'll make it a little bit easier on us. And again, you can go to ericpdollar.com. In the right column, you'll see all the information on how to donate. PayPal is the easiest, or you can send a check or money order. And I just sign those and send those down to the bank in Nevada. But let's go to these project updates right here. I think it's kind of a mix of kind of everybody. So why don't I add you guys in here. And then let me go back to this screen here. Group update on the telluric experiments and transatlantic trials. And for everybody listening, I will open up we'll open up for questions at the end. And then I'll just bring you in on video and or audio, and then you can ask the questions. So does anybody want to tackle this real quick or pitch in? I think you all are unmuted. So yeah, go for it.
Okay, so we did on the telluric experiments and the transatlantic trials, we did a preliminary trial last Sunday. This is involved Jeremy out with a Tesla transformer receiver in the sea.
What was it? 4? I think we had 4 sites running. So it was yourself, Gavin, Brock, and myself.
Do you want to kind of preface it with what this is about?
The rough idea is we had a few sites running sort of internationally all around, and the goal was to do a preliminary experiment using the ground as an antenna, or the ground as a propagation medium last weekend. And unfortunately, the conditions were pretty bad in every respect. The site I was at, I had a ton of interference from a nearby radio station. The weather was rainy, cloudy. The ionospheric integrity was not very good. The ground qualities were not very good. So we kind of didn't expect much to get out of it, and we didn't. But at least we got everything coordinated together, and it sort of gave us a good stepping stone to start building up from here. So I think Adrian maybe pick up.
Yeah. So we had the transatlantic trial was originally to see whether or not we could do telluric transference of power by telluric means
at extreme distance.
Yes.
Over obviously transatlantic implies very large distances, but even at short distances, I mean, I've done quite a few telluric experiments, which you can find on my website, and I've seen the telluric wave components up to about 30 miles. Beyond that, the radio wave component is the only component that I can measure. So it was an initiative preliminary between Jeremy and Griffin and myself, and we also had Bruce on the call as well, Bruce Gavin, obviously Eric involved as well. On the Sunday, we had Griffin and myself were operating transmitters, and
Hackas's running the receiving side,
right,
and also Bruce Gavin as well, also with the receiving site as well.
Do you want me to add Bruce in here?
Yeah, sure.
So you want to jump in, Bruce? Let's see.
Yeah, hi. I don't know whether you can hear me or not.
Yeah, we can hear you.
Okay,
I'm
great.
looking to where I can. Oh, almost had it.
So we didn't, as Hackas has said, there was quite a lot of other extraneous noise. There was also a DX competition going on, I think.
Oh yeah, that too.
Very unfavorable.
Which was a little bit unfavorable. We did decide whether or not it was worth going ahead, but we decided to see, look, let's see at least if we can come together. We can get everything coordinated, so we can do the transmit and receive. Start to get some of the problems ironed out with the systems. Try out our transmitters. We didn't receive any result. I must admit that wasn't surprising. We still have quite a few avenues to explore, and I think we'll be coming on to some more of that. Griffin, I'll pass to you.
Okay. Well, I would say that also following this experiment, and to the dismay of its, I guess, failure to some extent, like a learning opportunity, that I performed a smaller experiment. Now, I have a colleague who's situated around 2 miles away from my transmitting location, and he incidentally has a substantial ground plane of low impedance. So the initiative was to use 2 transmission setups in conjugate relationship. So one example of that I have right behind me. It's a Tesla magnifying transformer, and the receiving end was essentially the same image component of it, except that it was wound in the opposite direction for experimental reasons. Now, to my dismay, we did not achieve or detect any telluric component, but there certainly was a strong radio wave component. Nonetheless, the magnification factor associated with the transmission setup, which would significantly amplify any radio wave component down to the milliwatt level at such short distances. Now, in my personal experience, as well as I've informed Eric on the matter, that with simplistic coil setups, there exists two varying modes. And using very simplistic signal strength measurements, one could detect that in the optimum telluric mode, there ceases to be a radio wave component. And there exists a very strong earth or telluric downward facing, I suppose, component, which of course, if this is maximized in a certain respect, then you could achieve very far telluric distances. Now, this is of course another realm of experimentation, but the more coils which are concatenated upon the setup, the more you introduce imbalances in various nodes and what have you. So that of course just opens up another, I guess, 2 lifetimes worth of experimentation, which needs attention. But at the present, we are starting to venture into that direction.
I would just add also to what Griffin's just sharing. From experience that I've seen so far, I mean, we are working currently in the 160 meter amateur band. So specifically, we're working at 1.86 megacycles. And my experience of that so far is you can get the Tesla transformer to work perfectly well as a 1, 2, or 3 coil system. So a 3 coil being a primary, a secondary with an extra coil. You can get those working perfectly well, both at the transmitter and the receiver. But even in the LMD or the longitudinal mode, that mode just does not go through the earth. It gets absorbed. I mean, saying it colloquial, it goes into heating if I'm putting a kilowatt in from my transmitter, and I can check that the majority of that is passed to the ground system. It's heating the soil up around the ground. The 1.86 megacycles in any transmission mode that I've seen doesn't seem to go around very far in the earth. So
we know Tesla was operating in much much lower frequencies than we were. The reason we're using the ham amateur radio band is partly, licensing legality. The transmitters are basically built for these frequencies, so they're good for that. So ideally, we would just start with Tesla frequencies, but the coils are much bigger. Frequencies are much lower. They're actually closer to ultrasonic than they are to radio waves, 50 to 100 kilocycles. So we're trying to go the cheap way, and so far we're not having very good success. But it was try the easy stuff before you build the hard stuff.
Yeah, I want to point something out.
Go ahead.
Go for it.
Push me in.
Yeah, you're on.
So at any rate, there has been already very successful transmissions of this genre, not using antennas or what have you. I know Bruce Gavin did one. I did one between San Francisco and Los Angeles, and it does work. It provides a very effective means of communications. It's much stronger in many cases than a regular antenna, but somehow we're just not getting things matched up, and we're expecting too much out of it. So I'm not going to say at this point what's going through the ground or what's going through the air. All I care about is getting the signal 20 dB stronger than conventional stuff. I'm not. We don't know enough yet to to say, well, it just doesn't work.
Or we don't know if there's critical power levels that are required, or whether it's frequency, or the ground is a huge.
Part of it is the frequency is just too high.
Right.
But I was successful in Bolinas. Mm-hmm. Of course, Bolinas is a radiogeological anomaly.
And your ground was a miracle too.
Well, I was connected directly to the San Andreas Fault where it entered the Pacific Ocean. So there's those factors to take in consideration. But nevertheless, if using this particular frequency of roughly 1.8 megacycles, it's not to try to do it at the time in which that propagation is the worst, but do it at the time in which that propagation is favorable and not expect too much. This whole project needs to move down to around 500 kilocycles, and the power would be about 5 kilowatts. That's why I have a 5 kilowatt AM radio transmitter here specifically for that. It has the low band coils in it, so we'll go down into the 500 kilocycle maritime band. The only problem is getting FCC allocation and the money to hook the transmitter up and all that, because 5 kilowatt transmitter takes a little bit of power. We have that power available on the utility pole, but there's no means to distribute or what have you in the building. But that's the way it really needs to go. And then if I was to go to the Navy or something and say, well, let's go big time with this, I would start on 30 kilocycles, because the Alexanderson band, it goes from 10 to 30 kilocycles. Marconi and Bolinas used 44.77 kilocycles, and I believe Colorado Springs was 45 kilocycles. So we can't really expect a lot running up at 1.8 megacycles, but what can be expected is to, at that frequency, is to have a very effective mechanism of transmission, which has less noise and stronger signal, and doesn't require, a 315-foot mast in your backyard, but it's just simply a coil, with some kind of elevated structure. So what I'm seeing going on here, I think basically this whole thing's being approached wrong from the very basis. So what I'm looking at is there's a certain relationship between the characteristic impedance and propagation constant of the coil, that of the earth connection, and that of the elevated capacity. And this thing is not going to work unless there's exactly a 90-degree relationship between the low side of the coil and the high side of the coil, and a specific impedance admittance relationship between the admittance of the aerial capacitance and the impedance of the earth connection. So this is going to have to start off with lump networks like the tuning networks, the AM radio station towers, series inductance, shunt capacitance, and get used to this, which Steinmetz called constant potential to constant current transformation, and see how it works as radio. Because if all those things are matched up, I believe that this thing the performance of it will just flower. But we have to try and see, and of course that's a lot of work. We've got to make all the coils and capacitors and all that kind of stuff. But right now, from the theoretical standpoint, when I did the analysis on the scale model of the Colorado Springs, it was a distributed constant basis that I presented my analog of what this thing did. But one thing that hasn't been done is to do it on a pi network basis, because the Colorado Springs setup had kind of a heavy amount of capacitive loading, which you would not really expect if you're going for coil resonance, because it lugs it all down. But nevertheless, that's what Tesla did, and that thing worked good enough for him. So I'm looking at it from that standpoint. But what I had started here, which had been shown in the past, is this thing I call the Telluric Test Platform, which is kind of stalled right now because the Cable TV Shack is the high priority project and materials still have to be gotten. And my main guy that was working on that, he was on basically ready to die, and I had to take him to the emergency room 100 miles away, and he's not back yet. Fortunately, he didn't die, so I don't have him, and also presently do not have the money to pay for 2 simultaneous projects, but I do have the makings of a 2 kilowatt Navy transmitter that needs a lot of overhauling, because it was idiot left it out in the Arizona desert like he did the Collins for 20 years. But the objective is for whatever it is or whatever it ain't is a 1,500 watt, 1.86 megacycle transmission on a Tesla resonant transmission network of however it's going to be. And to have that thing, just like I have with the cable TV shack, there's a beacon that thing sends out all the time, as well as the weather beacon, a Morse code beacon. And just have that thing come on like every 15 minutes, identifier and what have you, and just leave it run 24 hours a day like that. And let's see who picks it up where, when. That's kind of, how would you say, that's kind of a top priority project here, to do whatever we can under all these adverse circumstances to build things that work. So that's one of them.
Okay.
The other, if I could just add, and the other possibility, Eric, is to consider not only the 500 kilocycle, but maybe the 136 kilocycle band as well, because that's also accessible to us.
Well, I know some people are not going to hear this, but I have a real attitude about ham radio, even though I have a ham radio license. Stay away from the hams, okay? Do not get involved with hams in any of this stuff at all. They're Fred Flintstones. They have this little poison in their mind that it's a hobby. And when the XYL snaps her fingers, they go into a trance and the key becomes silent. We call it the XYL QRT. Stay out of the ham bands. You can't do anything in the ham bands without some idiot that wants to butt up right next to you, even though there's 200 kilocycles to transmit and he wants to get 250 cycles away from you. Forget about the ham bands. And the power limitations are ridiculous. This stuff is, any decent radio transmission facility, power starts at 1,500 watts. 5,000 is about right. If you really want to make this something that, let's say the Navy is interested in, or that is practical, 5,000 watts, and not, obviously not in a ham band. So
the current limitation, I think, for 136 kilocycles, I think, is 1 watt.
Well, that particular frequency, now there is an old Bolinas allocation for KPH that's 120 something kilocycles or what have you. That was the first KPH broadcast out of Bolinas after the Navy kicked Marconi out. And that's a maritime band. I'm trying to keep this in the maritime bands because this is why RCA got me involved and supported me way back when I was very, very young, because they expected me to invent something that would make ship-to-shore communications revolutionary with conventional radio and get around the satellites, which was putting everything out of business at the time. So 120, somewhere around there, with at least a couple thousand watts, the coil would probably be 10 feet high, maybe 6 feet wide, something like that. And the ground system would be kind of outrageous. You'd have to drill a well, most likely. Adrian and I discussed this in the past and had come to the conclusion that the AM radio tower counterpoise is actually counterproductive, because it sucks all the lines of force down and doesn't let them go out into space like they're supposed to and terminate on the ionosphere. So the root type, like Tesla used at Wardenclyffe, is actually a better approach, or the buried electrode, like I have here with this massive water tank, is also a good way to do it. So that's the route I would have to go if it was anything that was going to be, of any actual significance in a usable naval or ship-to-shore maritime properly communication system, which is how all this got started. And needless to say, none of this stuff is going to happen on handouts. So the problem is where to get the money from and hire the people to do this kind of stuff.
Yeah, this is expensive to do.
Yeah, it's expensive.
But the scale is big.
Yeah.
The scale is big and it's expensive.
Okay. Hey, we're running on, it's 1:15 right now. We've actually packed quite a bit into this, and we're been on track pretty good. I'd like to open up for questions here pretty quick, but before we do, I'd like to see if Bruce, we haven't heard much from you. If you'd like to throw in any comments on the matter, and then we can open up for questions.
Yeah, okay. Couple of things that came out of the discussion around the failure of hearing any signals in the last experiment was that we should make sure that an effort's put forth to make the the coils that we're using on either end identical, and it may give us a chance to prove or disprove some more capabilities with that mode. But the communication that Eric mentioned that I had that was from a coil, I'll describe that briefly. There was basically a 9-inch by 10-inch coil tuned for the 160 meter band. It was a frequency of 1845 kilohertz. Happened about 13 years ago. And I haven't been able to reproduce it yet, but I haven't tried all that much. But it was from my place in Rhode Island down to Puerto Rico, where I worked a station, had a conversation like we're talking now for 10 minutes or so, back and forth. His receiver was a 2,000-foot long Beveridge. His site, after the discussion, I looked it up, and it was located on top of an abandoned copper mine. So he had some sort of deposits under there where the Beveridge was running. But there were no antennas at my site that the coil could have been coupling into. The coil was adjacent to a tall tower, which had a natural resonant frequency of about 5 megacycles. So it wasn't tuned to react to the coil I was using. So I sort of rule out that was playing any role in it. But nevertheless, it was enough of a demonstration for me to keep my interest in this. And I don't know whether it was a telluric transmission, probably not. There's a lot of salt water between my site and Puerto Rico. So it could have been launching some sort of a surface wave, perhaps. Anybody's guess is as good as mine. But it's, it could be a mode that could be discovered, maybe have some useful purpose, for, as Eric mentioned, island to island or some other use. But it has provided me basically a little bit of hope that there is something there that we should sort of pursue. Even if there's no immediate results, and with a goal perhaps, as Eric has stated, to get an allocation for a very low frequency, and perhaps some coordination to do some significant installation to try to basic on what Tesla's patents were talking about. So anyway, just chiming in from here.
Okay, thanks, Bruce. So let's go ahead and open up for questions. Please keep it limited to anything in a presentation that any of these guys have given at the conference, or anything that you've heard on this call or that you've seen on their websites. We don't want to get off into too much strange territory. So let's try to keep it on topic. And if we can keep the questions and the answers brief, we can get as many as we can in the remaining time. So if you have a question, I think there's a way that you can, rather than just unmuting yourself right away and asking it, I think you can like wave your hand or something like that, and I can pull your video up. Okay, go for it, John.
Yeah, I was very much interested in the content of this EM induction book that Eric's doing. Is it available yet? Can I?
Are you talking about the Heaviside? Are you talking about the Heaviside book?
Yeah.
So on emediapress.com, both part 1 and 2 are available as digital downloads. If you go to emediapress.com, at the top right corner is a product search. And if you type Dollard and Heaviside and scroll down, you'll see like the book cover. The book cover will either be part 1 or part 2 that comes up. And there is a discount if you add both part 1 and part 2 to the shopping cart. It'll take something off. Part 1 is available on Amazon right now as a paperback. Part 2 will be available as soon as me and Eric receives the proof copies to review those, and then we can make part 2 live as a paperback. So the downloads are on eMedia Press right now. Part 2 will be on Amazon as paperback here in a week or 2.
Terrific. Thank you so much.
Okay, sure.
I did see an older one here from Victor Sears asking about the RF and audio racks that were being constructed. Is that capable of ultrasonic frequencies, or is it limited to 20 kilocycles?
The modulation transformer is designed to operate between 100 cycles and 5,000. But I would expect the thing would output to about 20,000 cycles without too much dielectric heating in the transformer. But I would be careful with that because that transformer is one of a kind and I don't want to damage it. So basically 100 to 5,000 cycles is what it's intended to operate at. But I would expect 10 kilocycles would be no problem.
Gotcha.
Here, I just want to mention real quick again, till we get a question, I just want to mention that EPD Laboratories, Inc. Operates solely on donations. And if you can go to ericpdollard.com, that's how to support this work in the best way is to either make a cash donation or by PayPal, checks or money orders. And in the right column of ericpdollard.com, you can scroll down and you'll see the donation information in the right column. And I think, let me get those websites. I'm going to post these again just in case anybody didn't see them. There's some of my websites. Down at the bottom, there's griffingBrock.com. He's posting some blog posts fairly frequently on some of his experiments. And if you go there, I believe Griffin also has a donate link. If you want to send some money his way, he's always putting them into these experiments. There's am-innovations.com. That is Dr. Adrian Marsh's website. That's a resource with a lot of stuff in there on all these type of topics. Let's see, we got a question here. Okay, so Francis is asking, what about the guy with the top hat at the last conference? He got a signal transmission to the ground to work over 1,000 miles, didn't he? So that was Parker Edmondson, and there's somebody
I could
named...
speak on behalf of him.
I'm sorry, what was that?
Well, I could speak on behalf of him. I talked directly to Parker.
Okay, and
so
and then yeah, and his friend Nick was in Chicago, who was saying that he believed he was receiving these signals from down in the middle of Texas. Yeah, go
I've discussed with Nicholas as well. Now, we've come to the conclusion directly that it was, in fact, the radio wave component that Nicholas, his receiving setup, essentially consisted of the neutral wire in his main system. Now, granted that he is in a YY-connected area, that neutral line essentially acts as a single wire VLF antenna, so to speak. So because he was directly connected to that, that will in essence act as a decent radiating or receiving antenna. And Parker's setup, using disruptive discharge, operated at around 160 kilocycles from what he told me, and the power going into it was on the order of around 1,000 or 5,000 watts. Now, without getting into just the sea of QRM, man-made interference generated by a setup like that, that would certainly be perceptible at very far distances via ionospheric skip. So we did come to the conclusion of that, and it wasn't necessarily telluric in any respect.
I'll just add, if I could, Griffin, also, this is something which is of great importance in these experiments is it is not easy to determine whether the proportion of the radio wave and the telluric wave. And in doing the work to make sure it truly is, there are many claims over, people have gone a very far distance, and at the kind of frequencies they're working at with a ordinary radio transmitter, that's not that hard, particularly in the 160 amateur, for example, the 160 meter amateur band, it's not that hard to go thousands of miles. So making sure that these experiments are very rigorous in which components are being transmitted and received, and the proportion of those components is very important. Like I say, I haven't myself, even in the experiments that I've done, seen a telluric component beyond 30 miles.
Exactly.
And that was with a 1 kilowatt transmitter. But again, it's at 1.86 megacycles. Even if you do the experiment, one of the experiments on my website is a comparison between a single wire and a telluric connection, which only spans the distance of about 18 meters. In other words, from one of my lab rooms to the other. And if you look at the telluric component, you're only getting, you're putting hundreds of watts in, and you're getting about 100 milliwatts out over 18 meters. It's at in the 160 meter amateur band at 1.86 megacycles. It is heavily attenuated between those two. Whereas a single wire, of a single wire between the same points, you can get lots of power. You can get lots of power in the hundreds of watts in the receiver. So how we do these measurements is very important. I just wanted to add that. Thank you, Griffin.
Yes, and exactly that brings up one experiment that I did last April, where having a single extra coil, which is designated for the so-called 40 meter band, it possesses an immense magnification factor of around 900 numeric, and simply connecting that to the extensive ground system of stacked barrels, which I have buried in the earth, with a remote, or I guess an isolated battery operated receiver, one could in fact pick up stations all the way from Europe and from across on the East Coast. Granted, I'm on the Pacific. And because of the quintessential fading, it is ionospheric as well as with the other receiving properties. But of course, one could be led to consider that it is in fact going through the earth, even though we're not using any aerial or mast, simply a ground system. But because of the characteristics of the received signal, it does indicate that it is ionospheric. But nonetheless, using the magnification factor of one coil alone, you could achieve vast distances through transmission and reception, making it quite practical and I guess more appealing than to using, say, a 30 to 100 foot mast, which is quite cumbersome.
I have something to add.
Okay.
So this stuff, as you kind of hit upon, is it has to be isolated from the power lines. Otherwise, it's not really scientifically valid.
Exactly.
That's a very important thing. So, if you're connected to a YY system, you're connected to one of the world's biggest antennas, because all transformers are bypassed now. So I've got in the depth of that in the past, of how I have a little way of presenting it that would knock you out of your chair by visualizing, but we don't have time to get into that now. The other thing is we're not really dealing with Maxwellian concept of transmission at this point. We're dealing more with that of Helmholtz. So Marconi and Bolinas found that they were going to put up a 30-mile long so-called Beveridge antenna, even though Beveridge wasn't even born yet. But same thing, long wire for his 44.77 kilocycle transmission system. But then somebody found along the way that if they took that wire and they wound it into a coil, that it received as good or better if the wire was stretched out 30 miles. Well, the coil is not electromagnetism, or at least not, there's electromagnetism. Unfortunately, there's two definitions of it. I'm talking about Maxwellian electromagnetism. There is no Maxwellian electromagnetism. with the coil. It's what's called magnetic potential. So what we're dealing with here, we're not dealing with waves anymore so much as we're dealing with potentials and transmitting from point to point via potentials, and how that propagates. It seems to mimic the electromagnetic with fading or what have you, but I'm not certain about any of that. So again, I'm trying to point out, we're relying on all these theories and explanations which may not be useful to us anymore. And this is part of what's making everything confusing and difficult, but also what's making it fun.
Yes, that's why we have to keep an open mind, certainly, because, we really haven't a clue of what is occurring. In some respects, some of the results that we are obtaining just are outlandish, or I guess outstanding in the conventional electromagnetic sense, but would make sense in a different scenario. So it's really just how we interpret the results.
Indeed.
Hey, I'd like to get the next call scheduled right now on a set. How about 3 weeks from now on the 25th?
Sounds good.
Works for me.
Okay, and does 1 p.m. work okay, Pacific time?
Yes.
I'd like it better if it was earlier.
Well, noon would be about the earliest. I'm usually up till
12 noon is good. I quite like that.
That's 8 o'clock for you.
Yeah, it's 8 p.m.
120 degrees.
Call. Okay, so we'll do that. So for everybody listening, the 25th of February, noon Pacific time, we'll do another one of these calls, and I'll send out a couple reminders and stuff. And let's see, I just want to show the conference schedule real quick so everybody can kind of see what's coming together here. Okay, right here. So it'll be July 5th through 9th. The conference, the whole thing is a must see. You're going to see demonstrations and presentations that you're really not going to see at other events. So it's going to start on Wednesday. Usually this is kind of health wellness related, miscellaneous. This will Dr. Adrian Marsh will be talking on the Toltec type topics. One of my sponsors for the conference, I'm going to be showing a video. He's going to, I'm not going to say what it's about right now, but there is an engine component that he'll be describing in a project he's working on where the air coming out of it is cleaner than the air going in. Bench tests are looking at about 80% thermal efficient, which is blowing away what's supposed to be possible. Let's see, on Thursday, so where it says to be announced, these are just spots that I have open right now, and I'm going over different considerations for who might be speaking there. Let's see, Paul will be talking on one topic related to some battery charging circuits. This is something that we hope to be able to put into production that people can buy to kind of replicate some of the self-charging battery rotating energizer systems. Friday will be Eric Dollard it'll be a 4-hour presentation that'll start at 8 going all the way up to lunchtime, and then after lunch Eric and I will co-present on the audio rack. I'll just kind of give kind of a little background of how the project kind of came together and a little bit about that, but for the most part Eric will be going through it, and that's the one that we hope to be actually demonstrating once that gets completed sometime in April-May timeframe. Haka says we'll be doing a presentation. Slaying Maxwell's Demons, I believe, is
I think that's what we're going for.
The name for right now.
It's a good name.
And then Griffin will be going over the is it the shadow graph? You talked a little bit about that earlier.
The radiant tube and other bulbs associated with it.
Okay. And then on Saturday, Dr. Marsh will be talking on the taking the golden ratio concepts deeper into a 4-hour presentation dedicated to that. And when he comes to Spokane in April, I'm sure there'll be some developments that will become a part of this presentation. And then Jennifer, she presented last year on some of the off-the-grid stuff, and she's going to give an update of what she's incorporated and what results she's gotten. And then Griffin and Haka says will be doing a joint presentation here, kind of to be determined, but and this schedule is going to be a little bit flexible. There's something else I'm working on with Paul that'll blow everybody away. We're looking at putting it into a production-ready model to be made available for sale, hopefully before the conference. Maybe it'll be released at the conference, but it's a very important technology I'm not going to talk about right now, but it works. I've seen it. I know what it is, and we want to put it into people's hands. And then Jeremiah, there's a, we've been working on the Tesla turbine. This is a 6-inch one designed to run at 30 to 40,000 RPM. This thing is going to be a beast. We should have it running here in about just a few days. We got to do some generator tests and so forth. And earlier in the call, when Eric is mentioning the electrostatic generator, which is basically kind of known as the Trump generator, because Donald Trump's uncle, John G. Trump, who worked at MIT, developed one of these parametric type machines. He was mentored by Van de Graaff, and this was originally intended to be used to generate power in space, but it appears to be a completely reactionless generator, I guess you can say. There's no kickback to the prime mover, so when you load it up, it doesn't slow down the motor turning it. And being that it's intended to be run at high speed and also in a vacuum, will be the perfect companion to the Tesla turbine. We don't know if we're going to be able to get anything like that running before the conference, but that's kind of the plan. And then there'll be a few panel discussions. And of course, some of this might be up in the air, but that's what it's looking like. We're going to be opening up for tickets. In-person tickets is going to be limited to about 65 people. So as soon as you see announcements coming out that tickets are available, I'd recommend snagging them up right away, because this will be the 12th year that we put on this conference, and every year 100% of the seats always sell out. And we also will be offering live streaming. And I think other than that, any final comments? Then we can go ahead and wrap it up. Or any final quick questions from anybody? Otherwise, we'll see you on the 25th. Any last words, Eric?
No.
Okay, and yeah, make sure to go to ericpdollar.com, scroll down in the right column, and if you're able to contribute any donations by PayPal or through the mail, it's greatly appreciated. You can see that the donations absolutely go to these experiments and projects to keep furthering this work. So thanks everybody for being on the call, and everybody that called in, and this will be on YouTube here possibly next week. And until then, we'll see you on the 25th.
Darren, it's great.
Okay. Take care, everybody. Have a good weekend.
Have a good night.
Okay. Talk soon. Take care. Bye-bye.